I'm just going to go through all the properties first, and then we'll do the examples. The first one is called the product rule. The product rule says this: if I'm taking a log, any base, and I have a product of two terms, I can expand those. Since multiplication makes things bigger, I'll add those two numbers together. Next, we have the power rule. Log base anything of m to the power n. You cannot have exponents on logarithms. So this power goes in front. The third one is the quotient rule. Log, if I have instead of multiplication, if I have two terms that are multiplied to each other. Because I'm dividing and making things smaller, when this happens, I can separate them. The top one goes first, minus the one on the bottom. We have base to a power rule. The base to a power rule says if I have the same bases, remember this is the base of the log and this is the base of the exponent. They cancel each other out. I just have x. This is actually a carryover of two separate rules. We learned last section that log base a of a is equal to 1. We learned in the power rule that if you have an exponent, it goes out in front. So combining these two rules, this is an exponent, so it goes out in front. Log base a of a is 1, so it just equals x. So that's where it came from. This is a base to a log power. Now, what this one says is you have a base, any base, and its exponent is a logarithm? If the bases are the same, they cancel out. All we have left is just the operation, is just x. And we also have the change of base. Let's look at the examples. Example 1 says, express as a sum of logarithms. Log base 3, 9 times 27. Log base whatever. Here we have a multiplication of two terms. So we can add them. Now we solve both of these separately. Log base 3 of 9 is equal to x. And log base 3 of 27 is also equal to x. So we get 3 to the power x equals 9. 3 to the power x equals 27. In order to solve this, we have to have the same bases. 9 is made up of 3 times 3. 27 is made up of 3 times 3 times 3. So since we have the same bases, the first one equals 2, and the second one equals 3. So that means log base 3 of 9 is equal to 2. Log base 3 of 27 is equal to 3. And together they equal 5. And that's our answer. Log base 2 of p to the third plus log base 2 of q. Express as a single logarithm. So what do we do if we have a plus? Multiply them. So since they both have to have log base 2, since they do good. So then we take p to the third times q, and there's your answer. Now, this one express as a product. Log base A of 11 to the power -3. Log base A of the 4th root of 7. And ln x to the 6th. What do we do with the first one? What rule do we apply? Remember, logarithms cannot have exponents. So what do we do with this exponent? Put it in front, right? So the answer is -3 log base A of 11. For the next one, we have to go back to our rules of exponents. If you have, for example, the square root of x can be rewritten as x to the power 1/2. Because this is a square root, there's an invisible 2. This is called the root. That always goes on the bottom. And whatever exponent is on x goes on top. So the actual rule looks like this. If you have an nth root of x to whatever power, the root goes on the bottom. And whatever exponent is inside there goes on top. So how do I rewrite this one? How do I rewrite this? There's a 7. It's got to be a fraction since it's a radical. What goes on the bottom? What goes on top? 1. Because there's no power. If there's no power, it's automatically a 1. So that's how you convert radicals into exponents. This is an exponent, so it goes out in front. So it's 1/4 log base A of 7. And there's your answer. And the last one. Yeah, because you can't have exponents, so the exponent goes in front. 6 ln x. So those are all my properties. Let's look at example 4. Example 4 says express as a difference. Log base 2 of 8/w. Since it's a fraction, what do we do? Very good. Whatever is on top goes first, minus whatever's on the bottom. So it's also important to note that if you have a whole bunch of series of these logarithms, if it has a negative in front of it, that part will always go on the bottom. If it has a positive, that part will always go on top. So for example, if I had log of A minus log of B minus log of C plus 2 log of D, how would you put that all together? Well, first off, you have coefficient. So this one goes where? Right, so it becomes that. So they're all logs. Anything that's positive in front goes on top. So what goes on top? A and D squared. What goes on the bottom? B and C, yeah. So that's going to help us in the long run if we notice those kind of properties. Example 5. Express as a single log. This is log base B of 64 minus log base B of 16. So what's the answer going to look like? Which becomes what? Very good. And that's your answer. Very good. On your sheet, we have some common errors that people make when it comes to logarithms. The first common error when you hear the product rule, people think that you simply multiply those two terms together. No, that's not right. When you have a product, you have to add them. You cannot expand if it has a plus or minus inside the parentheses. You cannot expand them. You can only expand them if it's multiplied or divided. You cannot expand them if it's plus or minus. If you have the quotient rule, that does not mean you take the log and then the power rule. Because there's a difference. There's a difference between this one because of the parentheses. Log of m to the power 3 means log of m times log of m, where log of m to the third, if the m is cubed, then the exponent goes in front. So if you have a parenthesis raised to a power, you cannot put the negative, put the exponent in front. So those are most common mistakes people make with them. Again, these are all on your sheet. Example 6. Express as a series of sums or differences. Log of x squared, y cubed, z to the fourth. Actually, you want to pick up here next time? Because it's 20 after already. And we still have 5 or 6 more examples. Okay, let's finish this one, and then we'll call it a day. Call it a week. Again, I'll be here next Tuesday lecturing, but if you want to stay home and watch it on computer, you can do that. Or if you want to come to class, I'll be here no matter what. So we have a quotient to begin with. How do we separate the quotient? Well, first, right, so we have the top minus the bottom. Yeah, you're right. Since we know that rule, since we have a product here, these will have plus in front of it. This one's have a minus in front of it. Because that's what's going to happen here. Now we expand this. X squared plus log y cubed. Are we finished? What's last? Beautiful, perfect. So 2 log x plus 3 log y minus 4 log z. That is your answer. Yeah, we have 2 more after that. So we'll pick up from here on Tuesday.